So, hello everyone. Let's now discuss this question separate squares 1. We are given with a 2D integer array squares. Each squares of I is having xi, yi and length I. Now, the minimum y coordinate value of a horizontal line such that the total area of squares above the line equals the total area of the squares below the line. Now, bottom left point and side length of square parallel to the y-axis. That means we are given with these 0 comma 0. If there is a 0 comma 0, then I am having 0 comma 0 comma 1. That means a square of length or side 1 is parallel to 0 comma 0, and we are going with 0 comma 0 comma 2. Then there will be a square which is parallel to x-axis, and at 0 comma 0 is the bottom left point of the square and the side length is 2. So these are the squares given. Now what is our aim? Our aim is to find the line which divides this into two equal parts, and the area at the upper part is equal to the area at the lower part. Now this line can be an integer, but it is a float data type, but it will be like in the middle. It is not sure that it will be a 3, 1, 2 or 4 or 5. It might be something like 1.16667. Now what are the wrong approaches for this problem? Let us understand what are wrong approaches for this problem. I have tilted or rotated this graph so that you can get the middle part of y. That means I need something like here. So I have rotated uh, this such that you can understand. So I want this line where I can get the right side and left side areas are equal. Now let me remove this initially. Here I am having 3. Now how do I got 3? Here 1 square. So instead I calculate it as 1 into 1, which is 1, and here there is another square which is of side length 2. So 2 into 1 till here, only till here. 2 into 1 is 2. So 1 plus 2 is 3. Now there is another square. I only need only the rectangle's area, which is 2 into 1. If I add 2 into 1, 2 to my 3, then it will be 5. Now after that I have another thing, 3 into 1, which is 3, and if I add this to 5, it will be 8. Now after that I have 1 into 1. No, sorry, I have 1 into 3. I am adding this 3 into 3 squares length or the rectangle's area 3 firstly, and then I have another square here. This is my another square here. So I'll add 2 into 1, 2. So 3 plus 2 is 5. If I add 5 to 8, it is 13. Now I have something like another square here. If you see, it is something like here. Yes, here 1 square, and here this is the 2 by 2 square. So 1 into 1 is added firstly, this 2 into 1 is added next, and this square which is 3 by 3, I need to add this also. 3 by 1, here it is 3. 3 plus 2 plus 1 is 6. If I add 6 to 19, 6 to 13, it will be 19. So I think you got how I am storing these areas, but this will cause memory limit exceeded. Why? Because we are given this constants, right? 5 into 1 is 4. Imagine 5 into 1e4 will be 50,000, I think. Yes, 5 into 1e4 squares dot length is 5 into 1e4, and the length of squares of xi yi can be 1e9. That means 1e9, and I have to also store the last side plus 1. Imagine I'm at 1e9. Imagine I'm at 1e9. Then I am having another square which is having a length of another 1e9. Here if you see, length can also be of 1e9. Length can also be of here. Length can also be of 1e9. So when y is 1e9, at 1e9 I can also have another 1e9. So till here I will having a memory of 1e9. Till there, for 1e9 prefix area array, I will store the values or the area till there. And even there is a case that here also I need to store 1e9. That means 1e9 plus 1e9, 10 power 9 plus 10 power 9 will be something like memory limit exceeded. This would be the error. So the prefix sum will be causing me memory limit exceeded. So it will be something like sweep line algorithm. If you remember the sweep line, we will be using sweep line algorithm, but it is causing a memory limit exceeded error. But what is the intuition? So imagine I have this 100 is the last side. That means this is the last where I got a square. Now I need to have something like this line. I need to find out this line where the area to the upper and the lower, area to the right and the left will be equal. I need this. I need this line where this area and this area are equal. So imagine, just imagine that I have the area to the left is 2. Let me wait. So, so imagine this is my line. This line is breaking here, and the left area is 3, sorry 2, and the right area is 3. Now 3 is greater than 2. So what will I do? I'll go to middle, that means this side, so that it will be break and I can get something in the middle. So my intuition is, and take another example where I have 5 here and something like 2 here. Now my middle value is here. Now where should I go? I should go to the left side because I can get a mid value there. Why I'm doing this? Why I'm doing either right side I can go or left side, but every time I'll go to the greater side, so that even if I am having a size of the area of 2 and here the area of 5, and if I go here, then the middle area can be, there is a probability that I can get 2 plus 5, it is 7, then I can get 3.5 as my area, so that I go to the greater side. So what will be the algorithm? It will be like a binary search algorithm. If you see clearly, I am going to the left or to the right, and if this is the lower part is having lower area, then I need to go to the right side. If the upper side, the upper area is lower, the upper area is lower, then I need to go to the left side. So the first thing I'll write will be low, and what is my high. Low will be always initialized to 0. What will be my high? For that, imagine you are having here x comma y. They gave y is equal to something like 10, and the side length L is given as 5. Now imagine you are at y is 10, then my square size can be till going to 15. So I will also have some lines, or I can also have to uh, consider these lines where it can divide the area into two equal halves. So I need to consider these also, these lines also. So the high value will be considered after the high value will be considered after iterating max y, max of y plus side. So I'll go through every square and check which square is having the maximum y plus side. So high will be max of y plus side. After that, this binary search will start with while low is less than high. Now, here comes the question. So, you're not taking any left side or right side, not even taking this C-plan algorithm. How can you get your area? For that, for every time, I'll go through I'll go through for every square. I'll go through every squares, and then I'll find out the upper area and lower area. So that so that imagine if upper area is lower greater upper is greater than lower. That means this upper is greater than lower. That means I need to go to the left side, to the right side, so that low will be initialized to mid. Low will be initialized. Low will be initialized to mid, or else high is initialized to mid. So this is how you solve this problem. But there is an error here. Now I have low is lesser than high, and I am calculating the squares. But imagine something like low is 1.01234, high is something like 1.01235, and this at this point there will be no equality. There will be no equality of low and high, because it will always be not equal, because even though these two are quite uh, nearer, but they won't be equal if I don't do any operation for them. So low and high will be never equal at some conditions. So what will I do? I'll add something like, let me do one thing. Wait a second. Let me do one thing. Here I have 1.01234. So what will I do? I'll add 0.000 and 1. This is negligible or negotiable, so that I am trying to make low and high values are equal. And also, if I am adding to low, I need to remove this from my high. 0.00001. So if I remove this and add this from low, I'll add this condition. Wait a second. Right here, mid minus 1e, sorry, plus 1e minus 5, and mid minus 1e minus 5, and low is less than high, and we will return the answer at the end. I think you got this point, why we are going through the binary search and what are the wrong approaches, what is the algorithm of this binary search. But you might think that You might think that you have something like 0, you have something like 0 here, you have something like the last is something like 100. Then why can't you search for this 50? Why can't you search for this 50 which is having the area where I have the left and right is equal. But there is a case that 50 can also be here, can also be here, and I also go through the left. So if I search for something like 50, then I'll return at this point initially. That's the case where someone get the error that here also. If you see here, I think it is visible here 0 1 2. At 2 they are getting the area is 1 and the upper area is also 1, but I need to return the lower index where I got 1 so that this algorithm won't be working. So trying for the target where it is by one total area by 2 will not work, so that you need to go through low is lesser than high, and when low is equal to high you need to go out of the while loop. So this is how max will be high and square of 2. High will be initialized as I said square of 1, max of y plus side, and then low is lesser than high, and if upper is greater than lower, low is equal to mid plus 1e5. Upper is greater than lower, low is mid plus 1e5, and if not, high is equal to mid minus 1e5. So to calculate you will be using this iterating from squares, but you might think what will be the time complexity? What will be the time complexity? I also wondered how this would be run as I am going through all squares at a time. So let us start. The number of squares are n, which are of size n. Now, while high is lesser greater than low, that means the maximum I can get is 1e9. So this is my 1e9, and something like 1e9 it is negotiable, and the worst case is 1e9 is the side length, the maximum value. The high value can be 1e9 and the lesser value or low value will be 0 and the high value is 1e9. Now I can go through the middle. What I am doing here for binary search, if you see high is greater than low, that means it will use a log of 1e9. So log 1e9 base 2 base 1 triple zero triple zero triple zero of 1e9 will be something like 29. So log base 2 1e9 will be something like not greater than 30. So it is clear that this binary search is only taking 30 calculations, and here 30 is my log n, that means binary search value, and here n into 4, n is search for 30 times. This will be the worst time complexity of my solution. I think it's clear for you, and if you like this video, share it to your friends and subscribe to my channel. Thank you.